Hi everyone, I hope you all are good. So today in this video we are going to do one more question, and our question is Queen's permutation 2D as 2D. So we have already done this type of question when we have our array 1D. Okay, so we have to do it for 2D. And before doing this question, I just want you to remind that we have done a lot of question based on permutation and combination. So the logic of this question is similar to that question, right? That permutation question. So let's try to understand the question first, and then we have to decide which permutation we have to find, right? So what has given to us? You are given a number n representing the size of a n cross n chessboard. So we have given one number n that represents n cross n size of our chessboard. So n cross n represents size of our chessboard. For example, if n's value is 4, so size of our chessboard will become n cross n, that is 4 into 4 is equals to 16, and that represents our 2D array, and that is our chessboard here. Okay, now coming here, you are required to calculate and print the permutations in which n queens can be placed on n cross n chessboard. So we have to find all possible permutations on which we can place our n queens on n cross n chessboard. So let's try to understand. Our input format, that is number n. Output format is check the sample video and question. Okay, so this is our sample output. So keep one thing in mind also. Our queens are distinct. That means our queens are not similar. So we have already done this question in one day, where we have 3 boxes and 2 distinct items. So how we were finding permutations of this question in that case? These 2 are my distinct items. So how many permutations are possible in that case? That is 6. And what are the permutations? Let's write them here. So I can place my 1 here, okay, and here. So in this case my 2 can come here. In this case my 2 can come here. In this case my 2 can come here. And I have to find permutations. So what I have to do here, if my 2 is here, 2 is here, and 2 is here, 1 can come here, 1 can come here, and 1 can come here. So these all are the possible permutations. So let's try to understand the tree of this question, how we were making tree of this question. See, this is our item number 1, and we have 3 boxes. How many possible ways we have to place our queen? 1 can come here, 1 can come here, and 1 can come here. For item number 2, we have 2 choices to place our queen, right? See, 1 is here in this case, here, 1 is here, and 1 is here in this case. Now I have to place 2. So 2 can come here, 2 can come here, here. 2 can come here, and it can also come here. So 2 can come here, 2 can also come here. So these all are the possible permutations, right? Now, one more thing. Sorry. We have n. We have given n, and n cross n represent size of our chessboard. So I am taking value of n as 4. So my chessboard will become, okay, 1, 2, 3, 4. So my size of chessboard will be 4 into 4, that is 16. For example, now we have distinct queens, right? See, if I have placed q1 here, so how many ways I have to place q2? Just subtract queen 1, that is I have placed only 1 queen. So just subtract it from the total size of my chessboard. So q2 can come at 15 cells. It has 15 choices to place itself. Similarly for q3, 2 queens should have placed, right? So q3 will have 14 choices to place itself on chessboard. So let's try to code it now. So first of all, what I have to do, I have to take two for loops. I less than size of chess I plus plus. This is my inner for loop. Okay. And I less than size of chess and increment the value of j by 1. Sorry, this is my j. This represents my inner loop and this represents my outer loop. Now, I have to check chess ij is equal to 0. If it is equal to 0, what I have to do at chess I have to increment the value of my queen place so far with 1. Okay, so this is my queen place so far. This is my function queen's permutation, where I have QPSF as my argument, which represents queen place so far. Then I have total queen and chess board. Okay, vector of chess. Now I have to call this function permutations. So the QPSF, I will increment it with 1. So QPSF initially it is 0. You can see it here when I am calling it from my main function. So I am increasing the value of QPS by 1, then passing total queens and chess. Then I have to backtrack it out. I have to set my value here as 0 when my queen has not placed on right position. Okay, now I have to write base case here. So what will become my base case? If queen's place so far is equals to total queen, what I have to do? I have to print something. Okay, so for that I have to write my two loops. Then again I have to take one inner loop, increment the value of j by 1. Now if chess of ij is equals to 0, then I have to print something. We will see after some time what we have to print. Okay, and if it is equals to 0, then I have to print something, right? Then see what I have to do now. See the output format. I have to print my queen and 1, 2. That means number of my queen. So what I will print here, first of all I have to write q, then chess ij, and again space. Now similarly here what I have to do, I have to print this. Now coming here, I have to move my cursor to the next line. Again here I have to move my cursor to the next line and simply return. Okay, so let's run this code. So we are getting wrong answer, and why it is so. So let's try to understand this. Again we have done one mistake, right? So let's try to find out the mistake. Okay, so it is nothing but an issue of space, right? So we have to take care of spaces. You can see our output has got accepted here, but if I give one more space here, then you can see we will get wrong answer. So this is just an issue of space. So take care of this thing. Now let's submit this code. We will get our right answer. So we are getting correct answer. So I hope you have enjoyed this video. Thank you so much.